Okay, this is Unit 9, Target 2. Target 2 is about working with tangent ratios. All right, these are two special triangles that have ratios we know and can use, but we can't memorize different ratios for every other triangle. So for our 45, 45, 90 triangle, remember that the sides have a ratio of 1, 1, square root of 2. For a 30, 60, 90 triangle, we know that our sides have a ratio of 1, square root of 3, and 2. But we need to be able to work with every angle measure, not just 30 degrees and 45 degrees, or not just 60 degrees. We need decimal angle measures as well, and so we need to be able to do something different. Instead of referring to all the sides in the triangle as short or long or isosceles, we're going to start to use some different language. We already know the hypotenuse is the side across from the right angle, but we're also going to introduce the language opposite and adjacent. So, given the triangle on the left, okay, we have angle A in red. So angle A is the angle we're paying most attention to. And so from angle A's perspective, we still have the hypotenuse, which is across from the right angle. We have an adjacent side length, which is next to angle A. And then we have an opposite side that is across from angle A. And so from angle A's perspective, we have opposite, adjacent, and hypotenuse. Now the same triangle, but looking at it from the other acute angle, angle C. We still have the hypotenuse in the same location. The hypotenuse is always across from the right angle. But this time, the adjacent side is next to angle C, which is on the bottom, so this is the adjacent side. The opposite side is across from the triangle from angle C, and so this time segment AB is the opposite side. So the opposite and the adjacent will switch sides depending on the angle you're talking about. And with that, we can then use the language with opposite, adjacent, and hypotenuse. We can use that same language to talk about the ratios of any two sides of any right triangle. Just for practice in class, we said, okay, let's identify the hypotenuse. The hypotenuse is across from the right angle, so the hypotenuse is segment YZ. The side opposite angle Z, so angle Z is right here, the side opposite it was segment XY. And the side adjacent to angle Z was up here. The adjacent side next to touching angle Z is XZ. Some students do have trouble with the adjacent side, knowing which one's the adjacent. And so if you recognize the hypotenuse first, that'll help you with that step. Then we introduce what the tangent ratio is. So if ABC is a right triangle and angle A is an acute angle, then the tangent ratio is defined as the length of the leg opposite angle A divided by the length of the leg adjacent to angle A. We're going to refer to this as tangent of angle A is equal to the opposite side length over the adjacent side length, and you must know your ratios. So tangent is equal to opposite over adjacent. So if I'm looking at this triangle, pretty common 3, 4, 5 triangle, it is a right triangle. If we do the Pythagorean theorem, we'll see that 3 squared plus 4 squared is equal to 5 squared. And when it says find tangent of C, what they're saying is from angle C's perspective, what two sides make up the fraction? What is the ratio of the opposite side and the adjacent side? So the opposite side is 3 and the adjacent side is 4. So the tangent of C is 3/4, which you could also write as a decimal 0.75. The tangent of angle A, from its perspective, the opposite side is 4 and the adjacent side is 3. So as a decimal, that'd be 1.3 repeating. So the tangent ratio of an angle, every angle will have a different tangent ratio. Tangent of 20 degrees will be different from the tangent of 30 degrees, but it's always related to the opposite over the adjacent. Using our special triangles, what is the tangent of 45 degrees? So 45-degree angle, the opposite side and the adjacent side are both 1. So tangent of 45 is 1 over 1, which is 1. The tangent of 30 degrees is the opposite side 1 over the adjacent side 1 over root 3. We talked to you guys about how we're not really supposed to have a square root on the bottom. So if we multiply the top and bottom by root 3, we'll get square root of 3 over 3. And so sometimes if you type in tan 30 in your calculator, tangent 30, you actually get your calculator to say square root of 3 over 3. But the decimal that goes with that is 0.577, and I'll show you how to use your calculators in a minute. And a tangent of 60 degrees, this would be the 60-degree angle, is the opposite, so square root of 3, over the adjacent, which is 1. So square root of 3 over 1, square root of 3 divided by 1 is just the square root of 3. Square root of 3 is 1.73. I don't need to use a calculator to work with my special triangles. If I ask you for the tangent of 45, 30, or 60, the expectation would be that you draw the triangle out and then write down the ratio using your special ratios that you've memorized. Now, you can use the calculator, and so I circled where the sine, cosine, and tangent buttons are. On the TI-34 multi-view, this is a pretty common calculator. The one pictured here is a TI-30X. At TI-34 multi-view, you're actually going to press the second button and then the pi button. And right above the word pi, they have the word trig. That brings you to a trig menu, and you can choose tangent. On this TI-36 and the or TI-30 and the TI-30 multi-view, we're just specifically looking at the tangent ratio there. So when you type in tangent 11 on your calculator, you should get 0.194. If you don't, that means your calculator might not be in degrees, it might be in radians. Tangent 20 degrees is 0.364. I'm going to stop there because it's just typing in the calculator. And so we can also use the tangent ratio as an equation. So we have a 61-degree angle, and we will say tangent of 61 degrees is equal to x over 10, the opposite over the adjacent. I do not need the hypotenuse to do the tangent ratio. So tangent of 61 is equal to x over 10. We're going to multiply both sides by 10 because I'm already dividing by 10. So multiplying and dividing by 10 gives me a 1. So on the left side, I have 10 times tangent 61 degrees. And on the right side, I just have x. So 10 times tangent 61. 10, you can just hit 10 tangent. You don't have to hit times tangent 61. And I get 18.04. And so x is going to equal 18. We usually have been rounding to the nearest tenth, so about 18.0 or 18 units. All right, both of these examples, as the last two examples for target 2, are set up where the x winds up on the bottom of the equation. So for this first one, tangent of 57 degrees is equal to the opposite side 20 over the adjacent x. In the equation on the right, I have tangent of 15 degrees is equal to the opposite side 11 over the adjacent side next to it x. When x is on the bottom of the equation, we need to solve it differently than when x is on the top of the equation. When x was on the top of the equation, what we did was multiplied by that denominator, 10, to get the x by itself. Well, multiplying by the denominator in this situation won't get the x by itself, but it will get rid of x from the bottom of the fraction. So we're going to multiply both sides of the equation by x. You could do that on either of these equations or both of these equations. And what that does is multiplying and dividing this right side by x winds up with 20 times 1, because x divided by x is 1. And so now I have really x times tan 57 degrees is equal to 20 times 1, or just 20. Then as my last step, I need to divide by tangent 57 degrees on both sides. So x is going to equal 20 divided by tangent 57 degrees. And we can plug that into the calculator. 20 divided by tangent 57 degrees. If you have the fraction button, you can also use the fraction button. Okay, 20 over tangent 57. Both of those are going to give you 12.988. So that would round to 12.99 or 13. So x is approximately 13 on this problem on the left. The problem on the right, the x canceled. Then I need to divide both sides by tangent 15 degrees. So x is going to equal 11 divided by tangent 15 degrees. And I get about 41.1. And that is how to use the tangent ratio.